Hi everyone, I'm Huang from Huawei, and today I'm going to talk about CANN and ONNX, how we use ONNX for very high performance inference tasks. So first of all, just a brief memory lane of Huawei's open source participation in ONNX. We actually have been working with ONNX community with the China workshop and from the very start, dating back almost 4 years ago. And we have been participate each and every ONNX workshop, whether it's online or offline, as many as possible. In the community, we have spearheaded the Edge working group initiative. We proposed the ONNX Edge runtime architecture. So starting last year, Mindspore, which is our latest deep learning training and inference framework, has been using ONNX in a large scale. And today, I'm going to talk about our hardware support for ONNX. And this is what also this PR is about. So CANN is an AI heterogeneous computing architecture which supports users to very quickly develop AI applications on a CANN computing hardware platform. So CANN is for compute architecture for neural networks. A key feature for CANN is that it has a multiple layer of programming interfaces. So this multiple level of abstraction will enable developer to develop AI application more efficiently. So as you can see from the figure on the left hand, in CANN, we have the ACL for the overall API. We use ACL for the unified application programming interface. And lower down, we have the unified neural network graph construction interfaces, which is AIR as the standardized intermediate representation. And we have a very high performance compute engine and operator libraries. And we have a base service layer which provide capability like the drivers, virtualization, communications, and so forth. So in our latest release, the CANN 5.0, we currently have supported more than 140 ONNX inference models. And hopefully that number will reach to more than 200 by the end of the year. CANN 5.0 support offset 8 to 13 with the offset 11 as the key offset we can support. And more than 90% of the ops will be supported on CANN by the end of the year. And from figure, you can see from the 5.0 version to the earlier 3.0 version, we have a dramatic increase of performance. And you are more than welcome to check out our model zoo and check out the ONNX models we have been building upon CANN. So here are some future thoughts. That there are a couple of pinpoints that we have identified during our line of work, and hopefully the community will address these issues in the near future. For example, we found out that the PyTorch NLP and audio models export to ONNX is still very difficult. the trace mechanism doesn't support loop and if, and the torch script is really underutilized in the whole process of exporting to ONNX models. And also we have spotted there's a 35% to 40% failure rate when we export PyTorch model to ONNX models. The second problem we identified is that the iteration of ONNX offset is very fast. On the one hand, it's a good thing. It represents the fast development pace of ONNX community, but it also creates difficulties for hardware engineers, like the CANN developers, to do the ONNX adaptation work. Okay, here is the end of my topic. You are more than welcome to check out Ascend CANN. We have repos on Git and also on GitHub. Please also feel free to reach out to me if you got any questions. Thank you very much.